I used to get this feeling that the field of AI was just going so fast that there's no way I could possibly keep up with it. That it seemed like AI would be replacing humans left and right in no time. And part of this came from hearing claims on social media, everything from Zuckerberg claiming Meta will have mid-level AI engineers by the end of 2025, to the globs of YouTubers that seem to think, or at least want you to think, that every new tweet from Sam Altman means that AGI is imminent. But perhaps even more than all that, what made me feel that way was how I would constantly hear about this benchmark or that benchmark being surpassed by AI. At first, with GPT-4, it was the SAT, AP tests, the LSAT. Soon after that, it was solving medium and hard programming problems on LeetCode, and now it's solving PhD-level math and physics questions. And I think for anyone to see that, the announcements about AI breakthroughs and the claims about superhuman-level performance, it does make you pause. It makes you question whether AI is really about to start replacing humans in many high-skill industries. And the reason I'm making this video is to tell you that this idea of AGI that big tech companies and many AI influencers have sold you on is a lie. It's bullshit. AI is still fairly far off from being comparable to human intelligence, and in at least one key way, it's not even headed in the right direction. How could that be? How could I claim that we're not even headed in the right direction when AI can outperform humans on such a wide variety of tasks? Well, it comes down to how we measure progress with benchmarks and how those benchmarks influence the direction of research. Because not a single popular benchmark for LLMs out there that I know of actually measures intelligence. And that's because intelligence is not a measure of how many tasks you can do. This is the definition of intelligence: the ability to acquire and apply knowledge and skills. Every benchmark out there tests the ability of a model to apply knowledge. That part's covered. But none of them focus on the agent's ability to acquire that knowledge. And accordingly, current frontier models almost entirely lack the ability to continually learn. Yes, you can train them once, but after that, their ability to acquire new knowledge is severely limited. And that's a big problem. I doubt everyone watching will be sold on my argument from this alone. There are in fact a number of viable counterarguments to my view. You could bring up the point that current frontier models do actually learn via in-context learning, and following that, you could say that benchmarks that require in-context learning actually do test the acquisition of knowledge. And there are several other arguments that do have some truth to them. And don't worry, I will absolutely address those arguments. But first, I want to sell you on my vision of the future of AI and research in the field, because my view is quite different from the popular view, and understanding why I put such an emphasis on learning and why I think the rest of the field should too requires first developing a shared idea of what AGI should be, a definition that hopefully you and I can agree on, how we ought to define it, and what it will look like once we have it. And then once we've gotten through that vision of the future, then we'll talk about the problems with the way things are done right now, and the 3 key things that I think need to change to get to that goal. I myself work on AI research, and so to start, let me talk about the mindset I adopt when I work on my own research. Because when I work on my research, I don't think about how I can collect enough data, and I don't think about how I can make an agent big enough to know everything. That's simply not possible. There's an infinite amount of knowledge out there, and no agent can know it all. Instead, I think about how I can make an agent that can learn from anything. An agent that has goals and can autonomously control its data stream and teach itself based on those goals. And I find this to be a much more compelling, but also much harder problem. Because sure, AI can learn pretty much anything given millions of examples, but if it needs millions of examples to learn, well, then it can't learn anything. It can only learn things for which millions of examples exist. When I work on my research, I imagine creating an agent that I can teach just like I would a human. That means learning from a back and forth interaction rather than learning from millions of pre-generated examples. And I would also expect such an agent to be able to bootstrap that knowledge to continually learn on its own. It should be able to continue to learn autonomously even without a direct need for human intervention. And I can give you real examples from my own life, not just hypotheticals. When I ask ChatGPT for help writing a YouTube script or for YouTube video ideas, they are always awful because they don't fit with my personal style. I mean, look at these recommendations it's generating. AI that can write a best-selling book in 24 hours. Let's try it. Creating an AI that can predict your dream job with your personality. I mean, these ideas are incredibly bland, and perhaps even worse, they certainly wouldn't fit in with the style of my channel. When I see these sorts of failure cases, I want to be able to work with the AI, suggest changes, and have it learn so that next time it's able to give suggestions that are better and perhaps more in line with the types of content that I make now. And when I try to have AI write code in my favorite machine learning library, Equinox, it never gets it right because apparently 2,000 stars on GitHub is just not popular enough for sufficient training data to exist. So we're in this weird spot where AI can do these crazy things. It can ace PhD level exams, discover new drugs. It can even decode conversations between whales. Yeah, that's a pretty cool story if you didn't hear about that one. Yet it can't even learn the simplest of new concepts without at least hundreds, if not many thousands of examples in an incredibly expensive training process. That's the current state of AI, and we've come to this point because the North Star of the field, the most prominent notion of AGI, is this idea of the single all-knowing agent that has seen so much data that it can generalize to anything. That's unrealistic, and that view fails to incorporate the importance of learning. Interestingly enough, the field was not always this way, and you can find examples of continual reinforcement learning with a real focus on learning all the way back to as early as the 1930s, with Thomas Ross's thinking machine and Stephen Smith's robotic rat that can learn to navigate mazes. There are a lot more of these neat examples in an awesome talk by Andy Bartow I'll link in the description, but I think you get the point. Early AI was mostly about animal-like continual learning systems, and I can only imagine that that was because it was well acknowledged that intelligence is fundamentally about the ability to learn. Now, all of this is not to say that modern AI does not learn, because it absolutely does. It's to say that instead of having these separate phases for training, fine-tuning, RLHF, testing, and finally deployment, after which the weights will probably never change again, there should instead be a single phase where the agent is both learning and doing. So while modern AI has gotten more general in the sense that one agent can do many tasks, from things like making recipes to writing code, with the current popular direction of research, we'll never have an agent that can learn any task. And that is a big difference. So let's say that you're interested in this alternative version of AGI that I've proposed, a general purpose learning algorithm inspired by animal learning. And animals, of course, includes humans. How could we get there? I'd say that there are 3 areas of research we need to focus on that are often shied away from in popular discourse. 3 things we can't yet do well enough to get to that goalpost. The first one is something I've already told you about. It's continual learning, and this just means that the agent should never stop learning. Now, this one's pretty obvious given our definition, because if an agent isn't always learning, then it can't learn to do any task, and so it very clearly wouldn't meet our criteria for AGI. I do usually still get some pushback on this point though, and it's usually from people that claim that current LLMs like ChatGPT or Gemini do already learn. And they usually point to either fine-tuning, which is where you can train a model on a new task after its initial training phase, and in context learning, where you can give a model an example of something it hasn't seen before, say examples of how to use a specific programming library, and then it can use to learn what it has within its context. And this point is actually correct. Despite what I said, there actually are ways for an agent to continue to learn after its initial training phase, but there are some big caveats. Starting with fine-tuning is generally thought of something you only do once, not a continual process because, well, then you just call it continual learning. And if you do try to fine-tune the same model multiple times, you often run into several problems, like the model forgetting what it previously knew, which is referred to as catastrophic forgetting, or the model slowly losing its ability to learn over time, which is referred to as a loss of plasticity. There are ways to mitigate these sorts of problems, but there is more work to be done. The point on in-context learning is certainly more nuanced, and I have a whole video talking about why in-context learning is insufficient for my version of AGI, so I'll link that here if you want to know more about that. But the gist of the point is that keeping the model's parameters frozen limits the types of patterns that are learnable with in-context learning. And anything a model does learn in context is only learned temporarily until that information exits the context window. So that is point number 1. We still have a ways to go when it comes to continual learning, but it really is just the start. It also brings us to point number 2, which really goes hand in hand with continual learning, and it is the ability to learn from a single experiential stream of data, which I should say is the exact opposite of how current large language models are trained. When you want to train an LLM, for example, you randomly sample from billions of disjointed segments of text, things like passages from books, articles, research papers, transcripts from YouTube videos, and the like. and you feed these disjointed sequences of text to the LLM in enormous batches to train. But there's a problem with this. If a model only ever learns from disjointed sequences, it will never gain the ability to reason about how it should act over much longer time horizons, about how it should act over a lifetime of experiences. While the severity of this problem is not as immediately obvious as it is for a lack of continual learning, an example goes a long way here. So I'll give you an example directly relevant to this video and my own research. Think about how this video came to be, and how I came to care so much about this topic. I promise it was not because I asked ChatGPT for the top 10 video ideas for AI YouTube channels. I mean, look at these ideas. You saw these ideas earlier. They're grossly generic. In contrast, you're probably not going to find a surplus of videos on YouTube, if any, about the importance of continually learning from a single stream of experience. And that's because I myself have had a unique single stream of experiences that led me here that no one else has had. I started with an interest in self-study and reinforcement learning. That led me to a graduate program where the community was acutely aware of the need for continual learning. I worked on research in the area. I had all sorts of interesting conversations with people who thought about this in extreme depth. And I even tried to start a startup that failed because of a lack of existing continual learning methods. So when I go to work on my new research or to make a new video, I'm informed by everything that's happened in my past, by what I've learned, and by the specific events recorded in my episodic memory. Without experiencing the world through a continual stream of observations like we humans do, concepts like episodic memory and temporally correlated causality become meaningless. And to create something like this video or the type of niche research I do becomes impossible. At some point, if you want an agent to be able to deal with lifelong sequences of data, it's going to need to learn from lifelong sequences of data. And the only way to get those is for the agent itself to interact with the world and generate those experiences. And no matter how hard you think, I really don't think there's any way to get around this. You can't just strap sensors to someone, stick a camera on their forehead, and have them run around for 10 years like that. I mean, it would be hilarious, but it still wouldn't be the same. So that's point number 2. You need a continual, single stream of experiences. And with that, we finally arrive at the last point. The last blind spot we need to turn our attention to, and that is scaling with compute. Or more specifically, designing algorithms where more compute always leads to better performance. Now, you might be thinking, haven't we already figured this out? And the answer would be yes, we've figured out how to scale models to hundreds of billions or even trillions of parameters when we use giant batches of data sampled randomly from massive internet-scale datasets. But when we go to the continual, single-stream experiential learning setting, we absolutely have not figured it out. Do you know what happens if you try to train one of these massive models without a massive static dataset, or when you stop using these massive batches of data? Our current learning methods completely fail because they've been designed with a big data mindset from the ground up. And you might be surprised by how much those design choices impact the ability of these algorithms to work on continual learning settings. The methods of scaling that exist today are not methods that scale with just compute. They're methods that only scale with a combination of compute and data. And they are grossly inefficient when it comes to how they scale with data. So much so that you may have recently heard about insiders at tech companies talking about how LLM training has been recently running into data problems. I mean, think about it. After going through basically the entirety of the open internet, and then also their private data sets, they say that they're running into data problems. Yet a human could go their whole life only occasionally browsing the internet, or maybe never browsing the internet, and still be incredibly smart. It's clearly not a data problem, it's a problem with the approach. What we need are not methods that can gobble up more data, but methods that, when given more compute, can use that compute to extract more out of what they are experiencing moment to moment. And while we still have a long ways to go on this front, we have made some great progress in the past few years, and there are a lot of interesting ways to do this, from model-based RL to auxiliary tasks for representation learning to learning options and more. This idea of being able to scale with compute in the continual RL setting is actually my own research area of focus. And later this year, I'll be starting my PhD to continue working on just that. I want to make another video soon diving into all the ways that scaling with compute is possible and talk more about my own new research. If that sounds interesting to you, you should totally subscribe. I try to only post when I have something genuinely interesting to share, and if you're interested in this area of research, you might also be interested in this video where I summarize 2 years of my own research in just over 10 minutes. Or you can follow me on X for infrequent hot takes. And that is it. Thank you for watching.